of what are the different pieces of the puzzle through HVAC?
Okay, so of course, so H is the heating component. That's probably the most straightforward. It's steady state loss calculation through the facade. So you've got a U value, the thermal transmittance of however well insulated your building is. You've got an external temperature you're designing to, dependent on where your building's located, and then you've got an internal temperature you're trying to achieve. So that's quite a steady state calc. On top of that, for heating, you've got air tightness. So any air leakage, air infiltration. So that's heating. Ventilation, the V part is we have standards in terms of minimum amounts of fresh air you want to provide to the number of occupants in a building. And as we've seen with COVID, ventilation component is very important, and people are pushing to increase the ventilation rates above standards. For not just for COVID, but there's been many studies in terms of behavior, cognizant behavior with more fresh air. And then the AC is the air conditioning, and air conditioning as a whole is it can be heating as well as the cooling. Bit more tricky, the cooling calculation, because you've got your internal heat gains, your equipment, your lights, your computers, etc. You've then got people who have both a sensible and a lating heat gain component. And then you've got the facade. So you've got particularly solar heat gain on fenestration and glazing, which contributes to the heat load into a space. So what we do is we run dynamic models, because you don't want to oversize plant. So when the sun's on one side of a building, it's not on the other side. Right. So you must make sure the equipment, you've got enough cooling in the peak occurrence on every side of the building, but that's not going to happen concurrently. So you make sure the central plant is optimized for that dynamic peak cooling load scenario.